All right, welcome back, geometry students. Today's notes are titled 8-1, Ratios and Proportions. So let's get started. First off, a definition of ratios is just simply the relation of two quantities. So if I've got two things comparing to each other, I can write a ratio. Most common, we see a ratio written as a fraction. For example, if we have the fraction 3/4, it's a ratio of 3 to 4. So we could write that also with the word 3 to 4. Or there might be this colon, so it's looks like 3, 4, and so we read that 3, 2, 4. All right, so example number 1. The number of students who play sports at a high school is 520. The number of students, total number of students is 1,850. Write the ratio of athletes to students. So if I want to write the ratio of athletes to students, first off, anytime I'm writing a ratio or a proportion, very, very important that we write our ratio in words first. So in words, my ratio is athletes over students. Okay, so the ratio of my athletes to students, I can fill in then with the numbers. So athletes, I have 520, and then for students, I have 1,850. Now, always be careful, or at least always make sure that you always simplify. Always simplify your ratio. So if I simplify this, I can divide both by 10. 520 divided by 10 is 52, and then 1,850 divided by 10 is 185. So my ratio of athletes to students is simply 52 to 85. Okay, so next we can talk about proportions then. Proportions are written with two ratios set equal to each other. They are proportional to each other. And when we solve proportions, we always cross multiply. So as we've seen before, we can multiply the 6 times the x, and then multiply the 9 times the 18. Sometimes circling those help us do that a little better. So I like to always start with my variable, whichever one my variable is first, to keep on the left-hand side. So 6 times x is 6x. And then 9 times 18 is 162. Then I can just solve this, divide both sides by 6. So therefore, x is equal to 27. Okay? Next, we can solve this one, cross multiply. Sometimes instead of circling, you can just write the x down so we can know that's what we have to multiply by each other. There's the variable here on this left-hand side, so 4y minus 5 times 6. Now be careful. If we've got two terms here, think of those being like a parentheses. We're going to have to distribute that 6 to both terms there. So I'm going to rewrite that first. When I multiply 6 times 4y minus 5, 6 times 4y minus 5, that's going to be equal to 3 times negative 26. 3 times negative 26 is negative 78. All right, like I said, I need to distribute my 6 to both terms there. So 6 times 4y is 24y. 6 times negative 5 is negative 30. And that's equal to negative 78. I'm going to add 30 to both sides. So 24y is equal to negative 48. And divide by 24 on both sides. So y is equal to negative 2. All right, in my last proportion there, I've got 6 times 3z minus 1. I'm sorry, 3z plus 1. And then z minus 1 times 24. So be careful with this one. I've got a z in both sides, or there's variables in both sides. So it doesn't matter which one I multiply first. But be careful. When I have two terms, I have to distribute what I'm multiplying it by. So I'm going to rewrite this first. I'm going to say 24 times z minus 1 is going to be equal to 6 times 3z plus 1. When I write that first, I'm not trying to skip steps, just doing it all together. All right, 24 times z is 24z. 24 times negative 1 is minus 24. 6 times 3z is 18z. And then 6 times 1 is 6. I'm going to add 24 to both sides here. So I've got 24z, after that canceled out, is equal to 18z plus 30. All right, then subtract that 18z over. So 24 minus 18 is going to leave me with 6z equals 30. And then I divide by 6. Both sides, sorry, I'm kind of running out of room. Divide by 6, so I've got z is equal to 5. Okay, so in those proportions, I've solved for a variable. It means I can plug that number back in, and then these proportions would be true. Both ratios would be equal to each other. All right, so then example 2, using proportions. If we have a word problem that says a boxcar on a train has a length of 40 feet and a width of 9 feet, and the scale model is made with a length of 16 inches, find the width of the model. So I want to find this width of the model. Remember, we always want to write it in words first. So you can write your proportion anyway, but I'm going to write my portion of the boxcar length over the width, and it's proportional to, it's equal to the model length over the width. Okay, I could write length over width is equal to length over width, but one's the boxcar, one's the model, just to keep it separate for me as well. All right, so putting in the numbers there, the boxcar length is 40 over the boxcar width is 9. So 40 over 9 is going to be equal to the boxcar length is 16, and the boxcar width I don't know. So put a variable there, put an x there, and then I can just do my cross multiplication. So 40 times x is equal to 9 times 16, which is 144. And then I can divide by 40 to say that x is equal to 3.6 inches. All right. Last example 3 involves both ratios and proportions. So the ratio of teachers to students is 2 to 15. If there are 390 students, how many teachers are there? Okay, so I'm going to write my ratio in teachers to students. Okay, both times. So my first ratio is given to me, 2 to 15. And it says there are 390 students. Be careful, that does not go up top here. That's going to go on the bottom. 390 goes in the bottom because my students. My x is where I want to find my teachers. Okay, I always multiply the x first, so 15 times x is going to be equal to 2 times 390 is 780. And then simply divide by 15. And so x is equal to 780 divided by 15 is 52. There are 52 teachers in this school. Okay, hopefully that makes sense. Hope you guys are ready for more ratios, proportions, and we get into similarity soon. All right, have a great day. I'll see you guys later.